quick hitter of a unit. We've got 5 class periods left in November. Okay? Alright? So the first, or 2 of them I'm going to use up with simplifying radicals. Today we're going to focus primarily on square roots. Wednesday we're going to translate that into 3rd roots, 4th roots, 5th roots, 19th roots, all that fun stuff. Okay? Exactly. Thursday we're going to talk about inverse functions. Friday we're going to talk about how inverse functions become one-to-one functions. And then next week, Monday, we're going to take an overglorified quiz/test on radicals and inverses. Yes, that's next week. Okay? Because then that's the only day we meet next week. Yeah. Okay? So that's the next 5 class periods, which will take us through November. And we come back for the 2nd of December. And then we've got all of December on rational functions. Loves me some rational functions. Okay. Alright, so here we go with topic 4.1. Day number 1. Okay, so in order to start, we need to be all on the same page. We need to be speaking the same language. Okay, so this is a radical. It has 2 different parts. We'll start on the inside. The radical, the inside of the radical, is called the radicand. Okay. Anything that's inside the radical is called the radicand. Okay? There can be numbers in there. There can be variables in there. We can have powers going on in there. Okay? There's a lot of stuff that can be going on inside the radical. Okay? But all of it is called the radicand. The blue box outside the radical is called the index. Okay? The index tells you what root you're taking. If it's a square root, we don't write anything there. So today there's not going to be anything because we're going to deal with all square roots today. Okay? However, Wednesday we might be dealing with 3rd roots, and then there would be a 3 in that box. Or there might be a 5 if we're dealing with the 5th root. Okay? So now we're all speaking the same language. Okay? So we've got indexes and we've got radicands. Okay? So, from your old algebra classes, okay, a radical is in simplified form if there are 3 conditions that are met. Okay? The first condition is there are no perfect square factors left in the radicand. Or, if it's Wednesday, perfect index factors left inside the radicand. So from now on, and really this should have been already, from now on though for sure, the square root of 8 is no longer acceptable. Because 8 has a perfect square factor in it. Okay, so the square root of 8 would have to be simplified to be 2 square roots of 2 from now on. Okay. On Wednesday, the cube root of 54 would no longer be acceptable. It would have to be 3 times the cube root of 2. Okay. Second condition is there's no radicals downstairs in the basement. Okay. So we have to clean up our radicals in the basement. It's called rationalizing our denominator. And the third condition is we don't have any fractions or decimals inside the radical in the radicand. Okay. So those 3 conditions are the 3 conditions that need to be met in order to have a radical in simplified form. Now, there are two rules that we live by. So those are our conditions. The rules that we have to work with are these two. If I have the square root of a times b, I can write that as the square root of a times the square root of b. If I have the square root of a divided by b, that's the square root of a divided by the square root of b. Both of these rules work in both of the directions. Okay? Majority of the time, you're going to use the left one going to the right. But very close, you're going to use it going to the left. Okay? And we'll show both of those today. Okay? So let's talk about our three conditions for having a simplified radical. Condition number 1 said, no perfect square factors in the radicand. Okay? So we need to simplify the square root of 48. Now, there are many different ways that you can go about simplifying a radical. Okay? I am not set on one way. Okay? I know I am very familiar with what the perfect squares are because my 8th grade algebra teacher told me to memorize them. So I did. Okay? Since I deal with numbers all the time, they've always stuck. Okay? You might be a totally different type of person. You might not know what the perfect square factors are, so you might have to do something totally different. Okay? Again, there's more than one way to get from here to Mosinee. Okay? As long as we all end up in Mosinee and we all have hair, we're okay. Oh, Mr. Steckbauer, I didn't see you standing there at the door. Hey, did you hear?
You probably thought there was a bald guy standing here because you mentioned you had a rotten hair joke.
Mm-hmm.
Luckily, I have a lot of it.
You do have a lot of hair.
Yeah.
Yeah.
So you're going to or what?
Well, sometimes you got to get to Mosinee.
Sometimes.
There's many different ways to get there.
Yeah. Take the river.
You could take the river too. I never thought of that. Just got to get by the dam.
You're more than welcome to come visit me anytime you want.
Well, I know I can get to the river from your house, but that's not from here. I got to get through the dam first.
I live in Mosinee, so I figured come by, stop by.
Yeah.
Mm-hmm.
I'll see if anybody else is on there too.
Okay.
Oh, Miss Jordan.
Yes.
Yes.
Not in trouble.
He better not be because his homeroom teacher
But he'll come back.
his homeroom teacher would be mad at him if he was in trouble. All right, so the way I go about doing it is I see in 48, I see that there is 16 threes. Because 16 times 3 is 48. And the square root of 16 is 4. So I get the square root of 48 simplified is 4 square roots of 3. Okay? But that's just me. I know my perfect squares. Okay? You should get to know your perfect squares, by the way. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. 196, 225, 256, 17 is 289, 18 is 324. 18 is always the one I forget. Yeah. Okay. You gotta get to know them. So if you don't know them, okay, what's another way that you could do this? What? 6 and 8 don't help me because neither one of those is perfect squares. You know what I mean? But 4 and 12 are, right? Because that's a smaller one. I'll get to your 6 and 8 in a minute, by the way, too. That's the next way. Hint, hint. Right? But 12 is what times what? 4 times 3. So then this becomes the square root of 4 times the square root of 4 times the square root of 3. So then this becomes 2 times 2 times the square root of 3, which becomes 4 times the square root of 3. Okay? Another way. 48 you said was what, dear? 6 times 8, right? Okay. What times what is 6? 3 and 2. What times what is 8? 4 and 2. Oops, I should have done that the other way. What times what is 4? 2 and 2. And then I look for pair groupings because I'm taking the square root. So I'm looking for pairs. So then this would be a 2. This would be a 2. And then this one would still be the square root of 3. And then that gets me. Did you yell at him for having hair?
Yeah.
Yeah.
He's got a couple bruises.
Okay.
Yeah. Good.
All right. See you later, tough guy. Okay. With it? So you're looking for pairs then. On Wednesday, we would look for however many, whatever the index is. So if it's the cube root, we'd look for groups of 3. Okay? Handle? Simplify for me the square root of 8. I get 4 times the square root of 5. Yes? Should just be that one step. Okay? Don't care how you got there, as long as you all got there. Okay? So if you stopped at 2 times the square root of 20, you didn't make it all the way to the end. Okay? When we're simplifying and we're multiplying radicals, if we're adding and subtracting radicals, the radicands have to be the same. The indexes have to be the same in order to add them or subtract them together. When we're multiplying, okay, then it's outies and innies. So our outies can only go with outies. Innies can only go with innies. So one way of doing this particular problem, here number 3, is I could make this become the square root of 150. And then I could make this become the square root of 25 and the square root of 6. And the square root of 25 is 5, and the square root of 6 is the square root of 6. Another way I could have thought of this one is the square root of 2 times the square root of 5 is the square root of 10. The square root of 5 times the square root of 3 is the square root of 15. Then these two get combined into the square root of 25, which is 5. And these two get combined into the square root of 6, which then would get me that right there. Okay. You do number 4. I get 60. Because the square root of 100 is 10. Times 6 is 60. Yeah. Good. Second condition, we don't want radicals in our denominator, right? So the only thing that I can do when I've got a radical in my denominator is I can only multiply by 1. That's the only thing I can do. Because otherwise, if I multiply by anything else, it changes my problem. But the nice thing is that 1 comes in many different forms. So for instance, in number 5 here, I would multiply by the square root of 6 over the square root of 6. Because that is a fraction that's equal to 1. Numerator is the same as the denominator. That equals 1. By doing that, then my top, my new numerator, becomes 2 square roots of 6. My new denominator becomes the square root of 36. What's the square root of 36? 6. Now I've got a fraction without a radical downstairs. However, I can still simplify it because I've got two outies that are both even. So I can divide the top by 2 and divide the bottom by 2, giving me my final answer of the square root of 6 over 3. Okay? You try number 6. Don't erase it. Did you multiply by the square root of 12 over the square root of 12? That's fine. Yeah. And you just did it the long way. You decided to go out to Abbotsford to go to Mosinee. Still get there. Just take the scenic route. No, you can get there without going on the same road twice. Yeah, a couple of different ways here. You can multiply by the square root of 12 over the square root of 12. Get 7 square roots of 12 over the square root of 144, which is 12. Okay. And then you got to simplify. Okay. You could simplify first. Okay, you can go 7 over 2 square roots of 3, and then multiply by the square root of 3 over square root of 3. Okay. Or you can multiply by the square root of 3 over square root of 3. Okay. Lots of different ways. No fractions in the radical. Okay. Again, we don't like fractions upstairs. Okay. So here now, when I got a fraction inside of a radical, the very first thing that I do is I break it up into a radical of the top and a radical of the bottom. And then I simplify, or I rationalize my denominator, or I do some funkiness. Here I would multiply by the square root of 2 over the square root of 2. Square root of 9 times the square root of 2 simplifies out to be 3 square roots of 2. Square root of 8 times the square root of 2 is the square root of 16, which simplifies to be 4. Should be all on a stack. Okay. Go for it. Try number 8. I get the square root of 70 over 10. Okay. Now the downfall with not allowing radicals in the basement is the fact that sometimes you get ugly looking ones like this. Okay. Okay, what do you know what that's called? Yeah, it's called conjugate. Multiply by the conjugate. Okay? So a conjugate is for when we have a binomial denominator. So you got two terms in your binomial. You're going to use the same terms in the same order, but you're going to change to the opposite operation. So if it were 7 plus the square root of 3, then that would become, the conjugate would be 7 minus the square root of 3. Order of the term stays the same. You just change the operation. Okay? So here now, the conjugate of the denominator is 2 plus the square root of 3. 2 plus the square root of 3 is not equal to 1. So when I multiply, I've got to multiply by 2 plus the square root of 3 over 2 plus the square root of 3. So on the top now, I have if I take 4 times this binomial, I would have 8 plus 4 square roots of 3. If I multiply a binomial times a binomial, which we just spent a whole unit on doing that, okay, that's going to be 2 times 2, which is 4. 2 times positive square roots of 3, which is 2 square roots of 3. 2 times negative square roots of 3, which is negative 2 square roots of 3. And then negative square root of 3 times positive square root of 3 is going to be minus 3. When I simplify it, positive 2 square roots of 3 minus 2 square roots of 3, those both go away. 4 minus 3 is 1. So that I can just write as 8 plus 4 square roots of 3. Okay. You try number 10. My conjugate is 2 minus the square root of 6. So I'm going to multiply that both top and bottom. If I multiply it on the top, I get 2 square roots of 3 minus the square root of 18. Multiply it on the bottom, I get 4 minus 2 square roots of 6 plus 2 square roots of 6 minus the square root of 36, which is just 6. These middle two go away. Square root of 18 becomes 3 square roots of 2, because it's the square root of 9 times the square root of 2. So then that leaves me with 2 square roots of 3 minus 3 square roots of 2 all over negative 2. Or I could write it like that with the negative sign out in front. Or I could write it like that. Or I could write it one of those four. They all are the same. All depends on where you put the negative sign. So in a fraction, you can put it on the So it all really depends on where you want to put your negative sign. Okay? Homework for today. Due on Wednesday. As much as I want to give you a formative tomorrow, I'm not. We really could. I mean, I could give you a simplifying radical formula tomorrow. It'd be a quick one. Probably only take you 5 minutes. But we'll just use the homework as the formative for this one. Okay?